Okay, so now let's talk about the inverse function. Inverse trig function. Okay, inverse trig functions. So suppose you have some angle theta. Okay, so suppose sine theta is some number s. Okay, so what's the inverse function? Okay, what's the inverse function of the sine function? Okay, sine function. So let's look at what sine function did, right? Sine function change angle theta to number s. So inverse function by definition will change number s by 2 angles theta. Okay, so we use this notation for the inverse function. Sine inverse. Okay, sine inverse. So sine inverse function, the input is this s, and the output is the angle theta. Okay, angle theta. So sine theta is s if and only if sine inverse of number s is angle theta. Okay, is angle theta. So sine function change angle to number, sine inverse change number back to angles. Okay, back to angles. So let's look at some examples. Okay, some examples. So let's say our first example, find sine inverse of 1/2. Okay, 1/2. So now let's assume the answer is some angle theta. Okay, so first we rewrite it. Okay, we rewrite it as a sine function. Okay, so sine of angle theta is 1/2. Okay, so let's draw the relations again, right? So this is the angle, this is the number. So what's sine function? Sine function change angle to number, and sine inverse change number back to the angle. Okay, back to the angle. Okay, so now how to find this angle theta? We need our triangles again, right? We need our triangles in the xy coordinate. Okay, so now let's focus on this new condition. Okay, this new condition. So sine theta is 1/2. So what's the definition of sine theta? Is y/r, right? In the xy plane. So we got the y is 1, r is 2. So now what is x? Okay, what is x? So x squared plus y squared is r squared. So we got x squared plus 1 squared is 2 squared. So x squared is 3, x is positive, negative, radical 3. Okay, radical 3. Okay, so if you're familiar with 30-60 right triangle, you can see it's 1, 2, radical 3. Okay, 1, 2, radical 3. So now let's look at these two cases, right? Okay, two cases. So first case, we got a point x comma y is positive, radical 3, and 1. Okay, so the second case, we got a point, so we choose negative square root, negative, radical 3, and 1. Right, so this is our x and y. R is always positive, r is 2. Okay, r is 2. So now let's draw the right triangle, right? Draw the right triangle. So x is square root of 3, y is 1. So we have this right triangle. That's case 1, right? That's case 1. Case 2, x is negative, radical 3. So we go left, negative, radical 3. Go up 1, and then this is our right triangle. Okay, this is right triangle. So now what's the corresponding angle? Okay, what's the corresponding angle? So 30, 60. So opposite of 1, so this is 30, right? Opposite of 1, so this is 1, so this is 30. Okay, so the solution 1, the angle is 30. Solution 2, the angle is 150. Right, so this angle is 180 minus 30, so it's 150. Okay, 150. So we have two solutions if there's no restriction. Two pictures, two right triangles, two solutions. Okay, yeah. If there's no restrictions, we have two solutions, 30 and 150. So if you use radian measure, so this is pi over 6. So this is 5 pi over 6. Okay, 5 pi over 6. But for the inverse trig function, okay, inverse function has to be 1 to 1, right? So I give you a number, there's exactly only one angle. You cannot find two angles, okay, two solutions. That's a part of definition of trig, okay? So we have a domain of inverse function. So we have the restriction for this angle theta. So what's the restriction? Angle theta is between negative 90 to positive 90. Okay, yeah. So now you can see we have to keep this solution 1, theta 1, and then drop the solution 2, theta 2. Okay, drop the solution 2 because it's not in the domain of the inverse function. Okay, so the domain for the sine is positive 90 and negative 90. One more example, okay, one more example. So the key is the triangle, okay, is the triangle. So now let's look at, I change 1/2 to negative 1/2, okay? So let's find this angle theta. Okay, so again, we change this to the sine function, right? Sine function, sine of theta is negative 1/2. So I put negative sign on top because y over r is always positive, right? So we got sine theta is negative 1/2. So this is y over r. So what do we get? Y is negative 1, r is 2. Okay, yeah. Then we use the same equation to solve for x, right? Okay, Pythagorean theorem. There's a right triangle. We will draw two right triangles. Similar calculation, right? We got x squared plus 1 is 4. So x squared is 3. X is positive negative radical 3. Okay, radical 3. So what's the difference between these two examples? First example, y is positive 1, and here y is negative 1. Okay, here's the negative 1. So now let's write down the 2 points x comma 1, right? P1 x comma y. So this is radical 3 negative 1. The second point, second case, x comma y is negative radical 3 negative 1. Okay, negative 1. So now we can find this point P1 and P2 and then draw two right triangles. Okay, so radical 3 here, negative 1, so go down. So this is our right triangle. Okay, right triangle. And then for the second case, P2, so here is P1, right? P2 is negative and negative, so go here, negative radical 3, and go down, negative 1. Right triangle, so this is P2. Okay, this is P2. So 30, 60 triangle again, so we know this angle is 30. This angle is 30. Okay, yeah, so what's our first solution? Theta 1 is negative 30 degree. okay, it's a counterclockwise. Then it's positive, it's clockwise rotation. Then it's negative, okay, it's negative. And the other angle is a big one, is 180 plus 30. So theta 2 is, let's write on 180 plus 30. Okay, so again, there is a domain of the inverse functions. For sine is negative 90 to positive 90. So what's our solution? Theta 1, not theta 2. Okay, so this is the right answer. And then drop theta 2. Okay, so drop theta 2. Because inverse function has to be 1 to 1, only one solution. Okay, only one solution. Okay, yeah, so now let's look at one more sine example, and then we will have cosine and tangent example. Okay. So example 3. So suppose this is sine inverse of 0. Okay, so we assume this is some angle theta. So this implies sine theta is number 0. Okay, is number 0. So again, we use y and r because that's the definition of sine, right? Y over r, so y is 0, r is 1. You can pick any number for r, but we pick number 1 to make the whole thing easier. Okay, Okay, so here 0 is 0 over 1, right? So y is 0, r is 1. And then we have Pythagorean theorem. We use Pythagorean theorem to solve for x. So x squared plus 0 is 1. So x squared is 1. X is positive, negative 1. So again, we get 2 points, P1, P2. Okay, so P1, we have 1, 0. P2, we have negative 1 and 0. So now this is a special case. So we look at where is P1 and P2. So here is P1 on the x-axis, and the other one still on the x-axis, but is on the other side. Okay, on the other side. So now what's the angle? This is the first one. So terminal side is the initial side. So the angle is 0 degree or 0. 0 angle, no rotation. Okay, no rotation. So the second one, the angle, so this is first solution. Theta 2 is 180 degree or pi. Okay, or pi. So again, theta for the sine function is between 90 and negative 90. Okay, so we have to keep this one and drop 180. 180 is too big. It's not in the domain. Okay, it's not in the domain of the function. Okay, so now cosine example. Cosine is very similar. Okay, cosine is very similar. So let's look at cosine inverse of negative 1 over 2. So let's assume this angle is theta, right? And then we rewrite it by using cosine function. So again, I put negative 1 on top because r is always positive. So what is cosine? Cosine is x over r. So this is negative 1 over 2. We got x is negative 1. Numerator is numerator. Denominator is denominator. R is 2. So now we know x and r. So we use Pythagorean theorem to find y. Again, 2 solutions, right? 2 solutions. So it's negative 1 squared plus y squared is 2 squared. So y squared is 3. Y is positive, negative, radical 3. So it's 1, 2, radical 3, right triangle again. Okay, right triangle. So we have 2 pictures because we have 2 choices for y, right? For y. So P1, xy. So this is -1 radical 3. The second case, P2, x comma y. This is -1 negative radical 3. Okay, negative radical 3. Okay, so now pictures. So the first one, -1 positive radical 3. So -1 positive radical 3. So this is our P1. Okay, and the second case is -1 negative. So -1 negative radical 3. This is P2. Okay, this is P2. Okay, so now we know the reference angle inside here is 60 or pi over 3. Okay, 30, 60. So this is 60 because it's opposite to the radical 3. So now what's our first solution? Theta 1 is 180 minus 60. So this is 120. Okay, theta 1, 120. Theta 2 is 180 plus 60. So this is 240. Okay, 240. So we have two solutions if we don't look at the domain of the angle. So now what's the domain for cosine? Okay, what's the domain for cosine? Theta is between 0 and pi or 0 and 180. Okay, yeah. So we just make a rule to choose one of these solutions. Okay, to choose one of these solutions. So now for this particular example, the answer is 120, and we drop the 240 because it's not in the domain. Okay, it is not in the domain. The domain is between 0 and 180, 0 and pi. Okay, 0 and pi. So this is sine and cosine. Okay, sine and cosine. Similar methods, different domain. Okay, different domain. So now let's look at tangent. Okay, let's look at tangent. Tangent, number 5. So that's the tangent, -1. So tangent inverse of -1. So let's find this angle. Okay, so inverse trig, we are looking for an angle. Okay, we're looking for an angle. So this implies tangent theta is -1. Okay, so let's draw the relation again, right? Relation again. So here's the angle, here's the number. So tangent function, change angle to a number. And tangent inverse, the inverse function, change number back to the angle. Okay? So now what's the definition of tangent? So tangent theta is -1, so this is y over x. So y over x is -1, so we don't know which one is positive, which one is negative. Okay, so we have two cases. Case 1, x is 1, y is -1. So this is our case 1. Case 2, x is negative, and the y is positive. Okay, y is positive. So we have these 2 points, right? 2 points. P1 is 1, -1. P2 is -1 and 1. Okay, yeah, we don't need Pythagorean theorem to solve R. Okay, yeah. So now P1, 1, -1. So here is 1 and then -1. So this is the triangle. Okay, and then P2, -1 and 1. So this is -1 and then go up 1. Okay, so now 1 and 1, so we know this is 45 degree. The reference angle is 45 degree or pi over 4. Okay, pi over 4. So now what's our first solution? Theta 1 is negative 45 degree clockwise rotation. And the other one, theta 2, is 180 minus 45. So this is 135 degree. Okay, so we have two solutions for the tangent inverse, but which one we need to pick? Tangent and sine has the same condition, domain. Theta is between 90 and negative 90. Okay? Yeah. So we choose negative 45, not 100. So this is 35. So this is right. This is wrong. Okay? This is wrong. So we just make a rule to choose the angle. So now let's repeat, right? So sine inverse. Okay, so this is the angle theta. Sine inverse of some number s. This is some angle theta. So we need this angle between negative 90 and positive 90. Okay, so cosine inverse is also the angle. So the condition is between 0 and 180. Okay, 180. And for tangent is the same as sine. Okay, so this angle is between negative 90 and positive 90. Okay, so that's how we choose one solution for the inverse trig function in the end of the calculation. They're very similar. Okay, draw two right triangles and find one. One of them is the answer using this domain of the inverse function. Okay, yeah. So the domain of the trig function, range of the inverse function. Okay, range of the inverse function. Okay, so now let's look at trig equations. Okay, trig equations. So it's similar to what we did for the inverse function. Okay, yeah. So trig equations. Okay, equations. So now we only need to talk about the linear equations here. Okay, so I will give you 3 examples. So first example. Okay, first example. So let's say we have two cosine x plus 1 is 0. Okay, so step 1, solve for cosine x. Okay, so we imagine this is the new letter. We solve for this new letter. Okay, new letter. So minus 1 minus 1. We got 2 cosine x is negative 1. And then divide by 2, divide by 2. We got cosine x is negative 1 over 2. Okay, negative 1 over 2. Okay, so solve for cosine x. That's the important step. Okay, that's the important step. So after we solve for cosine x, okay, so we shouldn't use x, we should use angle, right? We should use angle theta, right? Angle theta. Because we use xy plane, right? We use xy plane. So now let me change it a little bit. Okay, so we know cosine theta is negative 1 over 2. We want to know the angle theta. Okay, we want to know the angle theta. So what is this? This is x over r, right? Okay, so let's change all these to angle theta. Cosine theta. Okay, so let me do this again. So 2 cosine theta plus 1 is 0. Minus 1, we got 2 cosine theta is negative 1, divided by 2, divided by 2. This is cancelled. We got cosine theta is negative 1 over 2. Okay, so this is better. Okay, so now what's cosine? Cosine is x over r in the plane, right? In the plane. So we got x is -1, r is 2. Okay, so we use angle, we use theta for the angle. Okay, x y r is the straight side of the right triangle in the plane. So now solve for y, and then we know point, we can draw the right triangle. Okay, x squared plus y squared is r squared. So we got -1 squared plus y squared is 2 squared. So y squared is 3, y is positive, negative, rod equals 3. Okay, rod equals 3. So we have the same situation, exactly the same as inverse function, right? We have P1, the first point is x, y, so this is -1 rod equals 3. So we choose positive square root. And P2, we choose -1, negative rod equals 3. Okay, so now let's draw the picture. So P1 is here, -1, rod equals 3. So this is P1. Okay, this is P1. And P2, -1, negative rod equals 3. Okay, so this is 60, the reference angle inside the triangle, this is 60. Okay, so it's 1, 2 rod equals 3 again, right? The special right triangle. This special right triangle. 1, 2, rod equals 3. So this is 30, this is 60. Okay, 60. Then we got two solutions, right? We got two solutions. One solution is 180 minus the reference angle, so this is 120. Another solution is 180 plus, okay, plus 60, so this is 240. Okay, 240. So for this kind of equation, okay, for this kind of equation, we keep these two solutions. So it's not inverse function, there's no one-to-one requirement, we keep both solutions. Okay, yeah, and normally we use positive solutions. Okay, so for trig equations, we use positive answers, positive angles. Okay, positive angles. So example 2. 3 sine x, we use theta, minus 2 is 5 sine theta minus 1. Okay, minus 1. So first step, we solve for that. Look at this thing as a new letter. Okay, new letter. Okay, so we move numbers and move sign, right? Plus 2 plus 2. So we got 3 times sine theta is 5 times sine theta plus 1. And then move 5 sine theta minus 5 sine theta. Okay, anyway, we cancel the 5 sine theta on the right hand side. So we got -2, sine theta is 1. And then divided by -2, divided by -2. Sine theta is -1/2. Okay, 1/2. So solve for sine theta. Okay, so sine theta. And then we use x, y, r, draw two pictures, right? Draw two pictures. So this is y over r. So we got y is -1, r is 2. So it's 1, 2 again. Then we got Pythagorean theorem. So x is positive, negative, rod equals 3. Okay, rod equals 3. Then we got two pictures, right? So it's positive rod equals 3, -1. So choose positive square root here. Positive rod equals 3, that's x. Y is -1, r is 2. Or you choose negative rod equals 3 for x. So negative radical 3, y negative 1, r2. Okay, r2. And then we have two solutions, right? This is 30. This is 30. Okay, so remember, normally we get the answer between 0 and 360. Okay, we want positive angles. Okay, we want solutions, positive solutions for equations. Okay, for equations. So this is theta 1, so this is the angle. Don't write down negative 30, okay? We want positive angles, so this is the angle. So solution 1 is 360 minus 30. So theta 1 is 330. Theta 2 is 180 plus 30, right? So it's 210 degree. Okay, 210 degree. Okay, so this is trig equations. So this is very similar to the inverse trig. Inverse trig, we only get one answer based on the domain or range. Domain of the trig function, range of the inverse trig function. And for the trig equations, we got two solutions, and they are both positive, between 0 and 360, or between 0 and 2 pi. Okay? Yeah. So this is very important, okay? For trig equations, we want the angle between 0 and 2 pi. So sometimes if you use degree angle, this is 0 and 360, positive angles. Okay, positive angles. So this is the trig equations, okay? Those are trig equations. So let's look at one more example. Okay, so an easier one. Okay, an easier one. Number 3. So let's say cosine x minus 1 is 0. Okay, so first we want to solve for cosine x. Plus 1, cosine x is 1. Okay, so first we got the trig value, right? So I use the angle again, right? I shouldn't use x, I should use theta. So this is cosine theta, this is cosine theta. Okay, cosine theta is 1. Okay, so now cosine theta is x over r. So this is number 1. So what do we got? X is 1, r is 1. Right, so Pythagorean theorem, you can see x squared plus y squared is r squared. So 1 squared plus y squared is 1 squared. So y is 0. Okay, y is 0. So we get our point xy. So point P, x comma y. This is 1, 0. So it's on the, this is our point P. Okay, this is our point P. There's no right triangle. This is a special case. Okay, this is a special case. So now what's the angle of this terminal side and the initial side are the same, so angle is 0 angle. So that's the solution. No right triangles, one solution. Okay, one solution. So that's a special case. Okay. So let's look at one more. Okay, let's look at one more cosine case. So 2 cosine theta plus radical 3 is 0. Okay, it's 0. So solve for cosine theta, right? Solve for cosine theta first. So minus radical 3 minus radical 3. We got 2 cosine theta is negative radical 3 divided by 2 divided by 2. Cosine theta is this, right? Cosine theta is this. Negative radical 3 over 2. So cosine theta is negative radical 3 over 2, which is x over r. So we got x is negative radical 3, r is 2. So Pythagorean theorem again, we got y, right? X squared plus y squared is r squared. So is positive negative 1. Okay, we already have this calculation a lot, so I skip some steps. So we have two pictures. P1 is negative radical 3, 1. And the second case, P2 is negative radical 3, y is negative 1. Two pictures, right? Two pictures. And then two solutions, positive angles, okay? So the first one, negative radical 3, negative radical 3, and then positive 1. So here is 30, okay? Here is 30. And then negative radical 3, negative 1. So here is 30 again, okay? Now what's the answer? The answer is not 30, okay? Is this angle start from positive x-axis to the terminal side. So theta 1 is 180 minus 30. Theta 1 is 150. And this theta 2 is 180 plus 30. So theta 2 is 210, okay? Positive angles. So this is the trig equations. Okay, we draw two triangles, most case, and then we keep both answers between 0 and 360 degrees. Okay, degrees. So now the last case. Okay, the last case is a little bit more complicated, but it's very similar. Okay, so let's look at this equation. So number 5, cosine 2x 2 theta is 1 over 2. Okay, so we use cosine 2 theta is 1 over 2. Okay, so there is the 2 theta inside. It's not cosine theta. Okay, it's not cosine theta. This is 2 theta. Okay, this is 2 theta. So now let's first change 2 theta to some angle. Let's say alpha or t. Let's use t. Okay, so we got cosine t is 1 over 2. Then we solve for angle t divided by 2. We got theta. Okay, we got theta. Okay, so now this is y over, so x over r because it's cosine. So x is 1, r is 2. Okay, so this calculation again. Pythagorean theorem. Then we got y is positive, negative, radical 3. 1, 2, radical 3. Okay, 1, 2, radical 3. So now two solutions. Okay, two solutions. So first one, P1 is 1 radical 3. So it's here, 1 radical 3. So 60. So this is not theta, this is t. Okay, this is t. And then the other solution. This is 1 negative radical 3. Okay, so the reference angle is 60. Okay, the reference angle is 60. So now we got two solutions. T1 is 60, and then this is T2 is, so again, we want positive angles. Don't give me negative 60. So this is 360 minus 60. Okay, so T2 is 300 degree. Okay, 300 degree. But we don't want T, we want theta. Okay, we want theta. So we can got T2 divided by 2, that's theta. But that's not all the theta we want. Okay, we want all solutions between 0 and 360. Okay, between 0 and 360, then what's the t should be between 0 and 720. Okay, 720. So we need one extra step for this question. Okay, for this question. Okay, so to find all the solutions between 0 and 360, okay, we have to make a new type of solution. Okay, so we know cosine is periodic function, So we know cosine of 60 is 1 over 2. And cosine 60 degree plus 360. They have the same terminal side, so this is also 1 over 2. Right? So if you use reading measure, so we know cosine, this is pi over 3 is 1 over 2. And then cosine pi over 3 plus 2 pi is also 1 over 2. Okay, 1 over 2. So now what's the general idea? General idea is, so if cosine t is 1 over 2, then we know cosine t plus 2 times n times pi is also 1 over 2 because they have the same terminal side. So what this part means, okay, so you got the angle t here. So this is t, right? And then continue rotate n times. You have 4 rotations, right? This is t plus 2 pi. Same terminal side, same trig function, same right triangle. Go around again. So this is another 2 pi. Go around again, another 2 pi. So you always go back to the same terminal side here. So they have the same trig value. So this 2n pi means go around n times. Okay, go around n times. So the solution is not only 60 and 300. We can add 4 rotations. Okay, we can add 4 rotations. Okay, so that's the hard part. So now what's our solution? So cosine 2 theta is 1 over 2. And 2 theta is t. So we got t is 60 plus T1 is 60. Okay, and then it also could be 60 plus 360, and 60 plus 360 times 2, and continue. T2 is, because they are the 4 rotations, they have the terminal side, right? T2 is 300, and we can have 300 plus 360, a rotation. And then we can have 300 plus 360 times 2. Okay, times 2. So now what's the corresponding theta? So theta is t divided by 2, right? So our answer, theta 1, so this is divided by 2, so we got 30. And this 30 plus 180. 360 divided by 2 is 180, so this divided by 2 is that, right? Yeah. So we got 210. So the next one is 30 plus 360, then it's too big. Okay, so we want all the solutions between 0 and 360. Okay, so now T2 divided by 2. So T2 divided by 2, say that 2, we got 150. And then this divided by 2, what do we got? We got 150 plus 180 is 330. And then other angles are too big, so we delete them. Okay, we delete them. So we have 4 solutions. 30, 210, 150, and 360. 330, sorry, 330. Okay, so this is a much harder question, because there is a double angle inside the trig function. So now let's look at another one. Okay, one more. the last example. I know it's hard, right? I know that the end is hard. The beginning is the same. Okay, in the beginning is the same. So let's look at sine 3x is 3 theta is 0. So again, there is a triple angle inside trig function. So first we change this to a new angle t. Okay, new angle t. So we got sine t is 0. So sine is y over r. So y is 0, r is 1. Okay, r is 1. Okay, so now what's x? X squared plus y squared is r squared. So we got x is positive negative 1. Okay, so we have two solutions again. So here is negative 1, 0. Here is 1, 0. Okay, so what's our first angle? First angle, T1. This is T1. T1 is 0. Okay, so I like to use degree angle. You can use degree measure. You can use radian measure. Okay, so what's T2? T2 is the other one, right? This is T2. This angle is T2. So T2 is 180. Okay, is 180. So now from previous argument, we know they're not all the solutions. Okay, not all the solutions. So now let's list all the solutions down here. I'm using another color, okay? So these are based on the given information, okay? So now what's all the solutions? T1 could be 0, could be 0 plus 360, could be 0 plus 720, 2 rotations and more, right? And T2 could be 180, could be 180 plus 360, could be 180 plus 720, and more, right? And more. So this is all the possible t's, and they all have the same terminal side. And then what's theta? Is that these t's divided by 3, right? These t divided by 3. So I'm going to change back to the red color. Okay, so now theta 1 is T1 divided by 3. So what do we got? We got it could be 0. And this divided by 3, 120. And this divided by 3, 240. And then the next one is too big to delete them. Okay, the next one is 360. Okay, 360 is too big. And then we got theta 2. We look at T2, right? 180 divided by 3. 60, and then this divided by 3. Okay, so it's 60 plus 120, so it's 180. Okay, and this divided by 3. So plus another 120, so this is 300. And other angles are too big, bigger than 360. Okay, bigger than 360. So anyway, this is the bad condition. We need all the solutions theta between 0 and 360. Okay, 360. So this is the last part of trig equations. Okay, trig equations. So now let me go back talk about this question again. So you find the two solutions between 0 and 360 for angle t. And then you list, okay, all these angles plus 4 rotations, plus 360, plus 720, plus 1080. Okay, if you're not familiar with it, you can use angle pi, right? So T1 is also 0 plus 2 pi, 0 plus 4 pi, and then 0 plus 6 pi. Continue, okay, continue. You can use radian measure. Okay, and then everybody divided by 3, you got theta. And then make sure after division, the angle is between 0 and 360. That's our solution. Okay, so that's the end of trig functions. Trig equations. Okay, trig. So we learned trig equations and trig, inverse trig. The important thing is draw two right triangles in the plane. Use x and y and r pictures and then solve the angles. Okay, that's it.